Assalamualaikum. My name is Muhammad Afnan bin Ibrahim. Today I will present my final year project. My title for final project is Mechanical and Electrical Properties of ABS and JMP Composite. This is my presentation outline. Now I start presentation with introduction. In my final year project, I used ABS and JMP for ABS is a polymer used in multiple industries due to its multifunctional properties such as its mechanical and chemical resistance. Graphite nanoplate represent a new class of carbon nanoparticle or nanopowder with multifunction properties. Besides that, electromagnetic interference or EMI is a phenomenon that may occur when an electronic device is exposed to electromagnetic field. Any device that has electronic can be susceptible to EMI. The EMI shielding material is used to reduce the problem by blocking or reflect electromagnetic radiation. The device must have portable charging carrier in order to deal the electric field in the bin. This means that the shield would be a conducting substance for electricity. Now we go to the problem statement and objective. My first problem statement is EMI can cause signal interference in electrical or electronic device. Second, previous used metallic EMI shielding material has many advantages such as high density hypothesis and material cost, corrosion, and lack flexibility. Third, ABS is a polymer material, thus electrical low conductivity. Last, nanographite tend to agglomerate when mixed with polymer, thus affect the filler distribution. For objectives, my first objective is to hypothesize the mechanical and electrical properties of ABS loaded with JMP based on critical review of filler loading effect on polymer nanocomposite. Second, to suggest the impact of electron-beam irradiation on the electrical properties of ABS and JMP nanocomposite. Last, to correlate the hypothesis properties of ABS and JMP nanocomposite with the morphological and structural properties based on review data. Now scope. Firstly, ABS used as a polymer material and graphite nanofiller as nanofiller. Various amount of graphite nanoplate 0.3, 0.5 and 1.0 in weight percent will be used. The samples are prepared by mixing and compounding of GMP and ABS polymer using single screw extruder to process nanocomposite shape. Next, the shape will be cut into the standard specimen. After that, electron beam radiation will be applied at each the sample to possibly increase the diffusion and prevent the agglomeration of single layer graphite and maintain the properties of graphite in ABS and JMP. The test sample will be characterization for their mechanical and electrical as well morphology observation. For literature review, I take two journals from Muhammad Bajarami and Vidaski. Now, methodology. First, I start with mixing ABS powder and JMP powder by using 3D mixer with speed of 60 ms for 1 hour. After that, the mixing powder was spread apart on a tray and dried in the oven at 90 Celsius for 1 hour. After that, after dry, made bending using single screw extruder machine with finding zone 180 Celsius, melting zone 180 Celsius and melting pumping zone 160 Celsius. Then we'll compress composite using hot press molding to get shape based at temperature 190 Celsius and press in 1 minute 30 seconds with pressure 700 psi. After that, to get the sample, the shape will be cut to standard specimen STM type 4. Then test the sample using tensile test to get mechanical properties such as tensile strength, young modulus, and elongation percent. For electrical properties, I use LCR meter to test electrical conductivity. And for morphological, I use scanning electron microscopy SEM for test. After that, I will get result and the result I will explain in next slide. Okay, this is the formulation of the experiment of JMP based ABS composite. As you can see, a value for graphite I use 0.3, 0.5 and 1.0 weight%. Okay, now I will explain about my result and discussion. First, this result are projected result and outcome based on critical review of various previous data. Okay, now this is expected result for the mechanical properties for tensile strength. As you can see, the tensile strength only slightly increased at 0.3 and 0.5% JMP. As the amount of JMP is increased to 1%, tensile strength show a decrease in value. The improvement of tensile strength by increased JMP content can be attributed to the uniform depression of the nanoplate with the polymer matrix, and the decrease in tensile strength is possible due to JMP agglomeration for composite with loading percentage both 0.5 weight%. Next, we go to the expected result for percentage elongation. As you can see, the chart pattern is increased at 0.3 and 0.5. After that, at 1.0 weight% is a decreased value show. Elongation at break decrease with the addition of JMP. The decrease is in the percentage of elongation can be attributed to the effect of JMP. The lower percentage elongation suggesting a more brittle characteristic. For young modulus, the chart pattern is show increase as the graphite content is increased, but at 1.0 weight% content JMP, it is a decreased value show. Young modulus increase with the addition of JMP. The addition of JMP could significantly increase the young modulus due to the larger aspect ratio of the JMP shape in the ABS matrix. Increase as much as 10% and 50% can be expected with the addition of 0.3 weight% and 0.5 weight% of JMP in ABS. Now, we go to the expected result for electrical properties. As you can see, a significant increase in electrical conductivity is expected with the addition of JMP. The increase in the electrical conductivity can be attributed to the good diffusion. The results show transformation happen when added JMP to ABS. Okay, now I will explain effect of electron beam irradiation. Okay, the chart The chart shows the increased pattern. Electron beam irradiation will increase the electrical properties of ABS JMP nanocomposite. By increase the magnitude of EB radiation on ABS JMP nanocomposite, it will improve the depression of graphite plate, thus achieve the electrical conductivity. Reason: EB irradiation, it will reduce the agglomeration of JMP in ABS composite and help JMP to disperse. For morphological analysis, morphological and structural properties of ABS based on review data. It can be observed that structure change drastically after processing largest polymerate dominant and a small number of graphite agglomeration can be seen. The region with formed polymer microfiber are present in the fracture area of the print ABS JMP sample figure E and F. Indicate a weak connection between graphite and polymer matrix, leading to ductile fracture of the specimen. Okay, for conclusion, it is suggested that the incorporation of JMP into ABS matrix increase the mechanical strength of the polymer. The decrease in tensile strength with loading percent above 0.5 weight%. Next, percentage elongation of ABS show a increased pattern when JMP is added. The decreased percent elongation means JMP made the composite more brittle. Besides that, electrical conductivity is significantly increased with JMP addition. The addition of largest amount of graphite greatly affect the mechanical and electrical properties of ABS. Lastly, EB irradiation is effective to improve the electrical properties in ABS JMP nanocomposite. Recommendation: there are several further recommendations that could be suggested to further improve this research. Use the material that has been completely clear to avoid bubble and void during compressing the material. Next, the produced sample must be stored in temperature and humidity control cabinet so that the properties of the sample can be maintained better. Okay, thank you from me. That's all.